fabric, the cloud, everything is full of AI. So my thought before Christmas was, hey, let's take a step back and go a little bit deeper into this AI topic. So we will have 2 episodes about AI. The first one is an introduction. The second one goes deeper in some sections. And basically the question is, well, hey, everything is AI, but do you really know the difference? What is machine learning? What is a large language model? And do you need which of these both, and so on. So basically this is the topic for today. I hope you enjoy it. Let's start as always with the architecture. This time there will be a little bit more architecture, a little bit less demonstration, because it's more a conceptual thing. So first of all, there is an evolution of AI, especially for data engineers, but basically for everyone else too, because the evolution of AI was more a generic thing. So it started in the 50s in the last century. So when we draw it, starting at 1950, around that, to roughly 1990s of the last century, there was the idea of rule-based AI. Rule-based AI means that you basically teach the AI how does the world work. How does a table look like, or how does a chair look like? And as you can imagine, things are a little bit complicated to teach. The idea was that you build some kind of expert systems, and that you create some basic, so if then rules, but life doesn't hardly follow if then rules. So this was an idea, but the results were, well, limited, right? So these were also the expert systems. Then, and of course, all this aligns a little bit with the compute power, obviously, right? Then roughly from the 1990s up to 2012, around that, machine learning started to grow. So this is the era of machine learning. So the idea was, hey, we can give some facts to the computer, and the computer can learn by itself how this works out, right? What are the rules? What is defining stuff? The problem is that in the end, the computer ends off with building clusters. So machine learning is often, are you in or out? So, right, so you build a cluster. The question is, are you in that cluster or are you not in that cluster? So this is a statistical thing. Obviously, it's unsupervised learning also. So we create statistical models. This can work very well, and it still works very well, but it means that you need to invest a lot of money and a lot of data, which is to some degree the same, to train that stuff. And you know whether it works or not after you invested the money. So this is hard, right? And it's not very successful in the broad approach. This is still used in things like spam filters, and recommendation engines. From 2012 to roughly 2020, you know what happened after 2020 most probably. This was the era of deep learning. This was the era of neural networks. And this is like the foundation for everything that is large language model, because large language built on top of that. This is also the era of image recognition. Is this a table on that image? Is this a dog on that image? And so on. All that popped up. and was widely used in a variety of apps and so on. But still, you needed to provide a lot of training data, a lot of testing data to get proper results. So the upfront investment was very high, and it all was always targeted to a specific use case. So I think that's quite important. It's always targeted to a specific use case, which means that you defined or found a specific use case, invested that money, and hoped for a big return. But in between, there was, again, the probability that this could go wrong, that the training doesn't give the expected results, and so on. From 2020 plus, at the end of 2025, this month, so this is again 5 years ago. It's amazing, isn't it? 2020 plus, this is the era of the large language models. Large language models means that you train the models with a big amount of data, so the training eats the main money, but after that the model is capable of solving a lot of questions, or all questions that the knowledge of the internet could answer. The quality depends on the maturity level of the model, so it goes better and better after each iteration of that models. But it can answer, so it can answer all different topics. You don't train the model for the first time for a specific area of knowledge. You train it like for a specific quality of knowledge, for a specific deep level of knowledge. That is part of the maturity, but the broad level of knowledge is like predefined and given and very broad. And it is very well suited for all kinds of natural language processing questions. So this was a big difference. It's called the foundational models. Foundation models. And the most well-known one, of course, is ChatGPT. And the second one, well, most known is, I assume, Copilot, which is integrated in almost all Microsoft products and GitHub products. So, like this is the evolution, right? And it's still ongoing. We are in the era of large language models. And this gives us a lot of capabilities, but there are very, very proper use cases for the previous generations of AI, because it's like, well, you can use a truck for everything, right? But a truck is not the appropriate car for every need. There are situations where you would prefer, I don't know, a roadster or something smaller, or you know what I mean, right? And same is true for AI models. So large language models, especially the latest and greatest ones, are great, but they consume a lot of power, which means for you a lot of money. And there are always areas where you can optimize exactly that. So what's the difference between machine learning and deep learning and large language models? So let's draw that, right? Let's do it here. I think that's nice. Let's take a different color. So we can start with large language models. I assume you are all familiar with large language models. Large language models, you have a text input, which is your prompt. This went to a pre-trained model. And this model makes some context understanding. And then it produces a text generation. it produces essentially tokens, but this is not important at the moment. Deep learning works a little bit different. Deep learning, the input of deep learning is raw data. Let's say some images, for example. This went to a neural network. And this neural network then extracts outer features. Features are in AI speech are properties of important properties of your suspects, right? Of your training data. Outer feature learning. That was not nice. Right, learning again. Outer feature learning, and out of that there is a prediction based on that feature. So that's widely different, right? You input data, there is a neural network, it makes some outer feature learning and then makes some predictions. For machine learning, it's again very different. Machine learning means you put in some structured data, not raw data, structured data. This leads to some feature engineering. So you engineer the features out of that, the specific and important properties. Then you select an algorithm to process these features, and you make a prediction out of that. So this is not, of course, not human-led, but it's with a lot of human intervention, and it's very, very different from deep learning, and it's completely different from large language models. Do you find workloads that are large language powered in Microsoft Fabric, and where do you find workloads that are machine learning powered? Just remember, everything that is large language model powered means you simply use that stuff, right? Everything that is machine learning powered means you need to build that model. So first, the question when we look at Microsoft Fabric and ask where is large language model powered AI workload. So we have Fabric, large language powered. Then we need to look at everything where we don't need to build a model. So first, of course, all Copilots. They are just ready to use. You don't need to train your Copilots. You don't need to feed a model with something for your Copilots. This is Power BI, Warehouse, Notebooks, Data Factory, RTI, all that great stuff. Then we have data agents. Chat your data. That works out of the box. You can use few-shot learning there. We will come to that in a minute. But beside of that, there's no special configuration needed. It's just the model just works. You don't need to do hours of training. We also have Azure OpenAI notebooks. Azure OpenAI notebooks. This means that you can use the OpenAI models right out of the notebooks, and the consumption is charged against your capacity. So you don't need to provide a dedicated OpenAI token, but you simply can leverage your capacity for like paying or being charged for that workload. So all that is based on Azure OpenAI service. This Copilots, data agent, and OpenAI notebook API. Where is your part? So where is machine learning? Machine learning. This is you. right? You need to train that. It's basically in all data science workloads. So everything that you kind of develop that is part of data science work, right? Which means machine learning experiments, machine learning models, creating your own models or selecting your own model, and everything in notebooks that is related to sklearn or PyTorch. So this is all data science workload, and this is like you. So you need to build that, and this is like large language model powered. Right? So that's like the differentiator in Microsoft Fabric. So basically, most of the AI you will most probably use is powered by large language models in Microsoft Fabric. So when should you still build your own AI, or when can you leverage large language models? So it's quite obvious, right? You can leverage large language models with a fingertip. It's so easy to use. But there might be cases where it's still be worth to create your own model. The question is when. So let's go a little bit into that question. So the starting question is always, what do you need? Your need. What's your business case? So first, do you need a text or language task? Text task. Let's keep it simple. Do you need a text-based task? If yes, then next question is it like a standard task? Standard task. Standard task could be SQL code, in our case, right? Summary, something like that. If yes, then you are in like pre-built large language models, things like Copilot, data agents. When you need a lot of domain-specific stuff, so this is a no area, right? Then you are in like custom prompting. Because you need a specialized prompt plus RAG. So you need to load your own data in. This is part 2 of our Fabric Friday AI focused series for Fabric enthusiasts. That's not for today. Let's assume you don't have a text-based task. So this is a no part of the text-based task. Do you have some kind of structured prediction? So, oh, it's a bit weird. No. So, structure. I switched. Structured. Structured prediction. What does structured prediction mean? So, do you have like a text that you need to process, custom text, or do you have like custom files that you need to process, and something like that? So, if you hear with yes, then question is, do you have training data? Do you have data to train your potential model? If yes, then you are in custom ML models. But well, you need your own model, right, to predict your own stuff. It's not like writing text or something like that. It's not about the input, right? It's about the output. So if you don't have training data, you're a little bit out of luck, right? You can use a pre-built model if some fits pre-built, or you need to collect your data first. If you don't have a structured prediction, so you have things like audio files or video files or images or something like that, then you're on the side of well, deep learning. And then you can go in Fabric with notebooks. With notebooks and GPU, right? Or you can use any other tool. Basically, you can hack your Python code on your own machine and then run some Azure machines. So this is a little bit out of the main area of Fabric. Yeah. But this is the area, so the no part, where custom stuff becomes more interesting. But you still see we have some pre-built area here. You can do custom ML when you need special structured data with your own training, or you can do deep learning with a special data set like audio data or something like that. But I assume most of the tasks are on the yes side, at least in my experience, and I think it's a very, very common way. So we need next to go a little bit more into large language model internals. There are 3 areas that we should cover. The first area are the tokens. So everything that you type, like build or create lakehouse, is tokenized. So this sentence produces 4 tokens, which the tokens are create a lake house. But the tokens are very different. Internally, these tokens, in a very, very, very simple way, are connected to each other. So you have these different tokens, and these tokens have connections to each other. And the large language model starts with the most prominent one, and from there works down every token path to produce the proper statistical correct answer to your question. So the tokenizing, basically tokens are like the words for large language models. This is the reason why the costs are always measured in tokens. So you have in every large language model costs per token. This is the OpenAI tokenizer, and you see the tokens are cut out of the human words into machine words. And we can even display the token numbers here. The second thing that we need to know is all that you write. So let's, for example, this sentence, like let's create a lakehouse, is part of a context window. This is number 2. Context window. The context window contains everything in your chat. Everything that you write, everything that the large language model answers, everything that you answer, and so on. Everything that you upload, just everything. This is the context window. There's a limitation on context windows. For example, for GPT-4, this is 128K. And once this limit is reached, because you uploaded a bunch of PDFs or whatever, then the upper part of the first part of the chat is like forgotten. It's ignored because it's out of window. So the window is created by your prompt, plus the grounding data, the things that you upload, the things that are automatically integrated, and so on. Everything that is on top of the internal knowledge of the large language model, plus the response. And because the large language model reads the whole content every time it creates a new token, so every time a new small token is added, the whole history is read, the whole context window, then you can add your prompts and the response has, because this happens again and again and again and again. So this is part of the context window, and once this is filled, this is too much, then you have an overflow. The third thing that we need to know is the temperature. The temperature means, well, it can be between 0 and 1. The temperature of 0 means that the answer is deterministic. For one model. But this rarely happens because you have different prompts and so on. We will come to that later. But just think about, you have a vanilla model and you have a temperature of 0, then always the statistically best fitting token is selected. When you type the same prompt, then you can expect the same answer, given that the model has not changed. A temperature of 1 is very creative. What happens is that the model starts to select a different than the statistically best fitting token for this answer. And because it writes token by token by token, like we have drawn here by token, the first token affects the second and both affect the third token that is selected. So once you add some creativity in there, the creativity has like an echo on the next token. So the creativity becomes more and more creative. Copilot itself has an approximately temperature of 0.7. So the answers are different each time you ask Copilot, which is intended. And this is okay. Regarding the tokens, keep in mind, first, some questions, for sometimes languages need more tokens than others. So for example, German has more tokens, about 20% more tokens needed than English. When you have rarely used languages, then the statistic, the base of tokens is also smaller, which will have an impact on the answer quality. This is especially true for rarely used languages. We have one in Switzerland, like Rätoromanisch. It's even in Switzerland rarely used. So the token body for this language, by definition, has to be smaller. That's literature and so on. So these are like the 3 things you need to keep in mind when working with large language models: the tokens, the context window, and temperature. So let's have a look at this prompt anatomy. I have talked several times about the system prompt and so on. Let's have a look. Prompt means you write something for the model, but the key is you are not the only writer. There's like the vendor, there are different layers of writers that write something that is hidden from you. So for example, that the large language model should always be polite or something like that. You don't see these prompts, but they are existing. So what's the hierarchy? The first one is a so-called meta prompt. So this is a prompt anatomy. The first one is a meta prompt. It's like locked, right? It's defined by the vendor. In this case, it's Microsoft, so Microsoft controls for Copilot. This contains things like safety rules, like behavior, or like constraints. The second prompt that you are experiencing, depending on your role, is the system prompt. The system prompt is defined by the developer or by the admin. And when you are the developer, you will define the system prompt. But let's assume you are not. So then this is also defined for you. This includes things like role. You are a poet, you are something, right? Like rules and examples. So this is the first, the second. The third prompt is context or grounding. Context and grounding means, this is typically, by the way, auto-injected. So this is done by the machine or by the workflow by definition. So some documents that are in the scope, some documents that are uploaded, and so on. These are like schemas, measures, chat, the pre-existing chat, right? And history. And other content. So. And last but not least, maybe the most important one from your perspective, is the user prompt. The thing that you are on, right? So show me top products or do something. So this then is leading to the user prompt. And all this builds all together, and all this, of course, makes lots of sense because you need some basic behavior. You need some examples. You don't want to start with a large language model bare metal. So this would be a bunch of work, right? So it's very convenient to have a user prompt, but from time to time you will also feel a little bit constrained, or like you want to get something and you have to really push the model in that direction. Then you typically are like ghosting an existing prompt behavior. But these prompts are sealed, so you can, in normal models, there are exceptions, but normally you cannot ask the model, please tell me your meta prompt. That's not possible. There are prompting strategies. The most important one is zero versus few shot prompting. So few shot prompting. Few shot prompting, very easy. First you have zero shot. Zero shot means you simply ask convert to SQL. Without any example. And then you get, of course, some kind of SQL, but depending on the maturity level of the model, you will get some assumptions, or you will get simply some SQL. That's it, right? So, but in the end, you will have inconsistent results. The opposite, or the better version, is usually like the few shot prompting. Few shot means you say, when I ask you show sales, then please use this kind of SQL. Select, write it here, right? So this is one shot. You can add more examples. When I ask you this, then please use this. When you ask you, and the people that have used data agents will remember the data agent, where they can do exactly that. You can say, when the user asks this question, then use this SQL. This is few shot learning. And after that, you will have a much better pattern matching. This is a short example of zero and few shot prompting. This is a zero shot prompt. Convert this to SQL, short top 10 price per revenue. You see, there are assumptions made. This is the key, right? This is a very mature model, so we got this annotation that there are assumptions made. Now let's include a few shot prompt, convert natural language example, and now convert this. So first we provide an example, and then we say, please convert this, right? This is like a one shot. And we get a much better result that is aligned with our needs. Now let's include few shots, multiple examples, and a little bit more complex query. And now the model is able to resolve even that complex query in a very nice way. You can imagine this like you have like activated or pre-warmed up the vectors of the model, which is of course not true, but it helps a little bit to get the idea why few-shot learning is so much a big help. And I can highly recommend that, especially when the results are inconsistent in your experience and you don't know how to improve them. So we went through different things here, right? We talked a little bit about the history, and you got basically the idea that the large language models are not really big and fantastic and amazing and so on, but that there's a really, really fundamental difference between you use stuff or you build stuff. And the main benefit in terms of convenience is that you can simply use the large language models and they can answer most of your questions in an accurate way because they have this token connections. And then we looked where large language model powered AI is used and where machine learning powered AI is used. What do you need? Do you need to build your own models or not? What are different main aspects that you need to know when you interact with a large language model, and how does the prompt anatomy look like? In reality, this is of course much more complicated. There's an amazing model that was built by Brandon Bycroft that visualizes that. This is pretty stunning. You see it here. And so when you want to go deeper, this link is of course in the description of this video, and you can follow this along. Always some community questions regarding the usage of AI and Fabric. So first, Copilot in Power BI, is it worth it? Yeah, it's very good for summarizations. It's very good for Q&As. It's good for code generation for DAX. However, the experiences are a little bit different there. It's very good for exploratory analysis. Well, you have, next question is, you have machine learning in Fabric, you have machine learning in Azure. When to use what? So for Fabric data science, integrated in the Fabric workflow, then Fabric machine learning is the best way to go. When you have like ML ops in place, when you have like GPU intense workloads, then you might want to go with Azure ML. But you can do hybrid. So you could, for example, you could do the training of your models in Azure ML and the deployment then in Fabric, and use the model in Fabric. There's also questions about semantic link. Semantic link in production is very positive. It's very nice for prototyping. It's a very good bridge for BI and data science teams. So when you are in semantic link, that's a good approach. There's always a question, what's the difference between zero-shot and few-shot prompting? Zero-shot are just the instructions, and few-shot are instructions plus 2 to 5 examples. More examples means better pattern recognition. Why does Copilot give different answers to the same questions? You know that already. There's a temperature parameter that adds some randomness. When your answer is cached, which can happen, then your answer should be identical for 48 hours. So what are next questions? What are system prompts and can I customize them in Fabric? System prompts define the AI's role, and in Fabric, Copilot uses Microsoft's prompt. It's not customizable. For AI skills, you have the instructions field. For data agents, you have also the system prompt, which is the same, by the way. And so you can define your system prompt there. Question: how many tokens does Copilot use per request? This varies. It could be between 500 and 1,000 tokens per request. With full schema grounding, it could be between 2,000 and 4,000 tokens. Output tokens cost 3 times of the input tokens, as a rule of thumb. Does Copilot in Fabric cost extra? No, it simply consumes capacity unit, Fabric capacity units. You don't need a separate license. Can you use your own large language models in Copilot? The answer is no. What's the difference between AI skills, data agent, and Copilot? So Copilot is your generic AI assistance. And AI skills or data agents are your specific way to chat with your data. Last but not least, the very common question is my data used to train Copilot? Answer is no. Azure OpenAI doesn't train models with custom data. Your data is only used to generate the responses, which means for grounding. Thanks for attending. Hope to see you next time. Next time we will go a little bit deeper into the AI topics with ragging and so on. And if you want to be informed when the next video comes out, please click on subscribe on my YouTube channel.